Treatment of greywater for potable use. Canada is the third most wasteful country when it comes to water usage. An individual uses an estimated 401 liters of water each day. However, we are the country with the fourth most available fresh water. So why do we care? Because of the prairies. Alberta, Saskatchewan, and Manitoba account for over half of the country's agricultural revenue. However, as climate change worsens, there will be increased droughts, fires, and warm winters that are all going to reduce the amount of water available in these provinces. This is going to result in lower crop yields, which will reduce the Canadian economy and global influence. We also care due to international ties. As a member of the Paris Agreement, Canada has a commitment to help developing countries combat climate change, which includes aiding and assuring access to fresh water. Through reducing our net water usage, we will have a greater capacity to engage in virtual water, allowing countries to focus their water usage on more essential needs. Why recycle greywater to remediate these problems? Greywater is all water coming from houses that does not contain feces, and it accounts for 45 to 70% of all wastewater in the residential sector. Through recycling greywater for potable use, Canadians will greatly diminish their water footprint.
The system that we've come up with to help mitigate this issue is a water recapture system that takes greywater and turns it into potable water in the home. The first step of this system is a septic tank. This is what the septic tank looks like on the inside. So we have the water entering through the inlet, and then over time it will settle out into 4 layers. The gaseous layer, the scum layer, which is the oils and greases, the wastewater, which is mostly water with some suspended solids, and the sludge layer, which is all of the solids that have settled to the bottom of the tank. The water will then be pumped through the outlet, and that is just this layer of the wastewater. From the septic tank, the water will be pumped to the sand filter. And at the top of the sand filter, we have a series of pipes that will allow the water to be dispersed over the entire top surface of the sand filter. And the water will be released and trickle down slowly through this sand filter, getting more and more filtered as it makes its way down. It will eventually be collected with the under drain and be pumped over here to the right. An important thing to note is that we have this valve at the top that is going to allow us to control the aerobic and anaerobic environment in the sand filter, which will allow for the proper balance of NH4 and NO3. Once we have the water pumped out of the sand filter, it's going to enter our final storage tank, in which chlorine will be added, and this will get rid of any additional parasites and any fecal matter that is left over in the water. And then we also have a spout here that will allow the user to obtain their water and use it for any purposes. The cost of this system is going to be approximately $26,000 for the initial cost, and there will also be additional costs for maintenance, such as power and cleaning of the system. If you have a previously installed septic tank, that will significantly reduce the cost of this system, as this number is for the entire system.
Possible ramifications. Though there are 6 topics that will be talked about on the slides, I will only be covering 3 as they are the most important ones. To start with, I'm going to be mentioning the social impacts. This system proves that wastewater is an important resource that should not be wasted. It gives communities an easier way to be involved in climate issues at hand, with all greywater contributed from households. However, as said in the design, there is a need for a septic tank, which can limit some of the clientele that is attracted to this product, for instance, apartment buildings. When looking into environmental considerations, droughts are a very common issue dealt with in Saskatchewan. There is a greater number of people watering their lawns and needing to keep their agriculture properly maintained. This design helps to save more water used for household agriculture, for the use of farming, or in areas of higher water insecurity. When looking into environmental aspects of our design, the way that the septic tank effluent is dealt with is much better than the conventional systems, as ours is going through a sand filter, whereas a conventional way disposes of the liquid into leach fields that have the possibility to contaminate the groundwater, affecting the organisms around it. Though the design is an expensive choice, as talked about in the design aspect, it can reduce money spent on hydro bills annually. For our future plans, before we are implementing this design into society, we will be having a learning period to see how long before the system needs to be cleaned, where it will go from a weekly to a monthly basis.